All right, we might get started. So hi everyone, I'm Shane and this is Ian.
Hi, how's it going?
We're going to talk to you about Houdini, yay, which some of you might have known as Glitter. This was the name we were using internally at Google. We're going to stop using the name Glitter. Glitter's going away, everything's Houdini.
Which means we don't get to play with like glitter anymore, but we get to play with like locks and
Ropes and stuff.
Yeah,
and,
exactly. Yeah.
All right, so what is Houdini? Houdini is a W3C task force jointly formed between the CSS working group and the tag to investigate and promote extensibility in CSS. Huh?
Wow.
Okay, so some of you might know what all of these things mean, and some might not. I'm going to assume that there are people who aren't familiar with the inner workings of the W3C and go through all of the bits. So W3C, the World Wide Web Consortium, one of the two bodies tasked with owning and defining most of the specs that the web works off. In particular, the W3C controls CSS, SVG, DOM, other bits and pieces like that, web apps, sysapps, all that sort of stuff. A task force at the W3C is, mostly at the W3C you have working groups, and working groups own like an area of responsibility. A task force is a joint responsibility or an area of responsibility that has multiple working groups subscribing to it. So in this particular case, the Houdini task force consists of the CSS working group, the people who define the CSS spec, and the tag, or the technical advisory group. And the technical advisory group is kind of this special umbrella group that is supposed to look after making sure that all of the specs are written in a similar way and expose similar ideas in similar ways. They're looking for consistency across the body of specifications. And extensibility in CSS, what does that mean? Well, we've got this idea of the extensible web, right? This idea that we build all of our APIs on top of base level foundational APIs, and those foundational APIs are supposed to explain how the higher level APIs work. And we're supposed to give out access to those foundational APIs so that people can do low level things if they need to on the web. And this is really transforming the way that we think about web content and working on the web. But CSS is still this huge black box, right? When you think about what happens with CSS, you get your style sheets at the top. There's a style computation, there's a layout computation, there's a paint computation, and you get to see the pixels at the bottom. And you have limited visibility, so you sort of get to see some stuff coming out of computed style. You can read some layout properties, you get some access into paint, and you have very little opportunity to customize or change the way that these things happen. And that's a problem, right? So the job of the Houdini task force is to try and open up this stack, to try and provide access to give web developers much more both visibility into what's going on and ability to modify and change what's happening. I should say at this point that most of the stuff that I'm going to talk about is very much the same as an internal brown bag discussion on Houdini that we run at Google. So if you're a Googler and you enter that discussion, I won't be offended if you leave. But come back for Ian because he's going to give some awesome demos.
Yes.
Right. So the inaugural Houdini meeting was held in Sydney Saturday the 7th and Sunday the 8th of February this year. It was held just before the CSS working group face-to-face. Myself and Rossin from Microsoft were are the co-chairs of the group. And we had a whopping 24 attendees. Now, when we were sort of talking about setting up a task force for looking at extensibility in CSS, we didn't think that it would necessarily be a very popular idea. We didn't think that there'd be a lot of people that were interested in looking into it. We were sort of picturing
like 10 or 12 type of thing, like a bunch of interested parties, nothing like the 24 that turned up. It was like, whoa.
Dark room.
Lots of people. Smoke-filled, mirrors, creating specs at midnight type of thing. Yeah.
But no, it wasn't like that. There was, lots and lots of people. And that was really heartening to see. And actually, I think it helped set the tone because the meeting as a whole was very positive and very, there are a lot of interested parties genuinely sharing useful ideas and approaches. So these are the hoodlums. Just breaking them up by company quickly. We had 5 attendees from Mozilla, including people like David Barron and Robert O'Callaghan, who between them I think know pretty much everything there is to know about the Mozilla codebase, and Simon Sapin, who was there representing Servo, which is a big Mozilla experiment to look at parallelizing the web, parallelizing rendering engines. So that, it was really important to have him there to sort of represent that future interest of the way that the web might evolve. From Apple, we had Dean Jackson. From Microsoft, we had Rosen, who kind of had to come because he was a chair, and Greg Whitworth. We had 3 people come from Adobe. We had 6 Googlers, Ian, myself, Rick Byers, Ian Bullock, Elliot Sperrin, and Tab Atkins. In addition to that, we had a few other independent people. So across the bottom, we have Peter Linz and Danielle Glasman, who are the co-chairs of the CSS working group, Chris Lilly, a W3C representative, and Elika, who I think, along with Tab, writes almost every spec that comes out of the CSS working group. And then the other 3 people were representatives from BiblioStyle, which is a spin-off of Antenna House, and they're very interested in doing web publishing style things, like actual almost books on the web sort of stuff. Right, so what happened? An overview is that we had some really great discussions about how to achieve extensibility. We did some deep dives into some specific areas and chose 8 areas to build specifications in, 8 new areas, 8 new specs. I'd say that's not the full story. I'd say there are more to come. But this is what we've started on. We are going to meet in Paris.
Yes, Paris after the CSS working group in August, or late August, yeah.
To talk about progress so far, and hopefully we will have made some significant progress in that time. So the meeting format was that we started with position statements from all of the attendees. Just went around the room and talked about why people were there, what they wanted, what they thought extensible CSS meant, what they wanted out of the meeting. And then we had a series of topic introductions with motivating examples, like I want to do this on the web and it's hard, sort of thing. And followed those up with a set of deep dives that ended up producing resolutions to create specifications. So I'm going to talk about the position statements first. These 2 sections I've kind of rolled into one just to keep things easier to understand and simpler. Now, I have to say with these position statements, these are just my observations of what the tone in the room was, right? If you actually want a position statement from Microsoft, Apple, or Mozilla about what they think about Houdini, you should absolutely go and ask them. I'm not claiming to represent them, and I don't want to try and represent them. This is just what it felt like to me being in the room, right? So Microsoft seemed to be particularly interested in custom layout, being able to extend the way that layout worked. And they have a big pointer interaction problem that they want to solve as well. Apple was very interested in querying APIs, read-only APIs, APIs to get information out of the stack. And they were also very interested in extending the way that the style engine works. They were much less interested and much more cautious about extending layout and style, and they were worried about
hurting performance in other parts of the pipeline as we think about it.
Mozilla had some concerns around lock-in, both vendor lock-in and technology lock-in, and I think these are really very important concerns to think about. So vendor lock-in would be if we went and built a bunch of specs that match a particular engine's internal implementation, right? That would be locking the future of the web into that vendor, and that's a bad thing to do. Technology lock-in would be building a bunch of specs that preclude us from doing potentially useful and important things in the future. Like, for example, building a spec that fundamentally never lets you parallelize parts of the web. And so it was good to have Mozilla there pointing out that we have to be really careful not to do these things. And the other thing that David Barron from Mozilla was talking about a lot was that the CSS core is getting bigger and bigger and bigger. There's something like 400 different properties in CSS right now. And every time someone wants to add a new feature to CSS, that adds to that number. Right? So it's just going to continue to grow without bound.
It's also sometimes an n-squared problem. Like if you add a new layout property, for example, you have to add it to every single existing layout. If you want to add a new layout, it has to support all of these properties. So it's a bit of a high cost there for adding these things in as well.
Right, like there's been raging arguments about how to deal with absolute positioning in Flexbox. Or,
And align items as well on like other layouts as well. It's just N-squared problem.
So there was a real desire to try and push things out of the core and slim down to a sleeker, faster, probably red.
Yeah, red.
CSS engine.
Yeah.
And Adobe was very interested in line layout, text APIs, tooling, all the sorts of stuff that that sort of follow their business interests. They want to do page layout on the web, and they're interested in APIs that make that easier. Okay, so let's talk about the motivating examples, and I'll also follow those through to the specs that were created. First up, we had Chris Lilly stand up and talk about drop caps. Do people know drop caps? They're like where you take the first letter of a paragraph and make it big. Right. Drop caps are really interesting, right? They're a feature that has a pseudo class, first letter, and I think it's 5 specific CSS properties. Initial
letter size, font. I don't know.
But anyway, five CSS properties and a pseudo class is all in support of being able to make this feature work, right? So it's a fairly heavyweight feature. They're used on a tiny fraction of web pages, right? Like you almost never see them used in the wild. It's only on publishing web pages. Even newspapers don't tend to use them, right? Like newspapers on the web favor just simple text. They don't tend to put embellishments like drop caps in. So it's heavy feature, tiny proportion of web pages. Now, I'm not trying to say we shouldn't support it. It's obviously an important part of the web and it needs to be supported. But it's a very, very good test case for looking at, well, could something like this be implemented as a set of custom rules on top of a slim CSS engine, right? It's also a good test case in the sense that it requires a bunch of different stuff. You need good font metrics, so you know what the actual size of the character is going to be when you blow it up. You need to be able to do custom line layout to say, well, this character is going to take up multiple lines, so exclude future lines from that region, right? In the worst case, it's recursive because changing the size of the first letter can change the composition of glyphs rather on subsequent lines, which can change their line heights, which can mean you need to go back and change the height of the letter again so that it fits on an integral number of lines, right? So it's a hard thing to do.
And then you add in different, character support as well, which have different types of baselines, alignments, and just very, very nasty and good font metrics as well.
And this is probably why we spent like 5 to 10% of total working group face-to-face time over the last 3 meetings, trying to specify this thing. It's hard, right? Nevertheless, Adobe actually came forward and said, you know what, we've polyfilled this. We've built a drop caps engine for the web. And we just faked a lot of that stuff, right? And it pretty much works most of the time, like 95% of the time you get a good result. But the really hard things, the part that we had a lot of trouble getting right was font metrics. And we really think that if you just had a better font metrics API, we could do a really, really good job of this. So we resolved on building a font metrics API for CSS. Right, and this is basically just an API that will give you lots of information about glyphs and runs of glyphs. Things like height, width, baselines.
Baselines, all the different character type lines. I can never remember them.
Yeah.
Yeah.
Fun stuff. And then Daniel Glasman got up. Now, Daniel Glasman is he's the owner of a company that specializes in building editing environments for style sheets on the web, right? So that he has a CSS editor. He's got various extensions to the CSS language which he builds into the editor. And as you change things in the editor, then the page that you're editing live changes and updates with the results. And he got up and described all of the problems that he has in trying to build these kind of environments, right? And in particular, there's 2 that I want to concentrate on. The first is parsing values in JS. So you get a value out of the CSS object model. It might be something simple like 40 pixels, or it might be something complicated like a linear gradient function. And you need to parse that into something that you can use where you can pull up the bits and see what's in there. And you're on your own, right? So every web developer who wants to make use of the output of style has to go and rebuild a complete value parser, right? This is wrong. We shouldn't be doing this to people. We should have a standard set of parsed representations of values available directly out of the CSS object model, right? The second big problem that he was talking about was how to deal with custom extensions to a language. So you've got CSS, you want to add a little extension to it, but that means you need to do inflow modification of style sheets as they land on a page, right? Something that's also really, really hard to do on the web today. So we went into a pretty in-depth discussion of what these things should look like, and we ended up producing a CSS, or describing the need for a CSS parser API. And there was discussion there about whether it should be token level access or parsed tree representation, or maybe both, and a CSS properties and values API. And I think this is the big one. This is the really exciting one. This is basically a combination of the next step from custom properties level 1, which is an existing CSS specification that lets you define your own properties but not do much with them. And then all of this typed value access. And even things like, hey, if you want to add your own custom value type with a JavaScript parser and just plug that into CSS as well. Hopefully this spec will let you do that sort of thing too. Is there anything I missed on that?
No, I think that covers it, yeah.
And Ian got up and talked about custom style, custom layout, and custom paint. So Ian gave a BlinkOn presentation at BlinkOn 3 about this, where he described, if you think of the CSS engine as a pipeline, these are 3 very natural places for extensions. We did deep dives on the layout and paint parts of that, given that we'd already sort of talked about style with the properties and value stuff. There was lots and lots of enthusiasm for both areas. There was a recognition that these are, letting web devs define their own layouts and define their own paint, or their own paintings, is something that we should be doing. Apple was very, very concerned in particular about layout, very worried about the performance implications. There was a really interesting discussion that played out where the representative from Apple was sort of saying, we probably wouldn't want to do custom layout because we'd be worried about the performance implications of web pages if you had JavaScript running in the middle of layout. And then a bunch of other people piped up and said, yeah, but wait a minute. People are already doing custom layouts and the performance already stinks, right? So, maybe we should be making it easier for them to do that and helping them perform a little bit better rather than falling off a cliff. So it was a really interesting conversation. We resolved to add 2 new specifications, CSS painting for custom paint hooks and CSS layout for custom layout hooks. Rick Byers talked about scrolling extensibility. He has a property and 2 functions or 2 event style things that can really give you a lot more richness in how you handle scrolling. So scroll blocks on to say which scroll events you want to block on the main thread before the scroll is applied, and then apply scroll to describe how that scroll gets applied to a scrolling region, and distribute scroll to describe how things that overflow the scroll region get applied to their ancestors. There was recognition, again with a little bit of disagreement from Apple, that there was a clear need to solve these problems, but there was a lot of concern about these being synchronous APIs that forced scrolling back to the main thread. In the end, we resolved to add a CSS scroll specification. The idea is that this and there's a CSS and CSS asynchronous
style, yeah.
So there's basically 2 specs. One of them which presents the case for doing scrolling synchronously on the main thread, and one which presents the case for doing scrolling asynchronously. And we're going to sort of let them get to a certain level of maturity and then compare and contrast, decide whether we need both or whether one of them will be sufficient to handle the needs of the web in the future. Rosen got up and talked about the box tree. This one, I think this was the one with the least contention. Like, we really want to be able to measure layout. We want much better access to measuring layout than what you currently get. It's a hard problem because of fragmentation, anonymous boxes and stuff like that. But also all of these things like fragmentation and anonymous boxes produce results that you just have no visibility into at the moment, right? So we really need to open all this stuff up. Unlike all of the ways that you can sense information about layout at the moment, you really don't want this API to force a layout to happen in order to read the data back, right? You want it to be asynchronous to call you back when the information is available. And this led to the creation of this fragment tree API, which I think is now called the box tree API. It was the box tree, then it was a fragment tree, and that's the box tree.
Yep. Like shitting.
And then Ian Volek got up and talked about asynchrony. So he presented a raft of different asynchrony ideas. There was a lot of interest in many of them, especially the ones around DOM, things like being able to bud pieces of the DOM off and run it separately, or being able to do some limited DOM creation off thread rather than in the main thread. But ultimately, the group felt that the Houdini task force was not the right place to talk about those things and suggested taking it to the web apps working group first. with the understanding that if the Web Apps Working Group didn't want to touch it, then Houdini would revisit. But there was one thing, asynchronous style, which I think is the project known as Compositor Worker within Blink, right? And this was, there was a lot of interest in this, and in particular, it was seen as an alternative place to put the extensible scrolling hooks, right? And the idea of Compositor Worker, for anyone who doesn't know, is it's a thread that gives you very limited access to some styling properties and runs with an affinity that is not necessarily the main thread. So it could be the main thread, but more likely it's the compositor thread or a third thread, right? So it lets you do some things off main thread that you currently can't do today. I think, Ian, you're going to give a talk about that tomorrow. 1:15. 1:15 tomorrow, right? 1:45 tomorrow. Okay. And that led to the last spec, the CSS async style spec, right? So in conclusions, many effective, much meeting.
Wow.
Seriously, though, there was a lot of support for CSS extensibility. It was really great to see just how important people felt that this problem was. You know, it's something that I think web developers have really felt pain over for a long time, and it's great to see that there's a lot of concerted effort towards coming together and fixing this issue. So Ian's going to give some really awesome.
Yeah. So I was just going to give a quick demo of of a prototype I built of custom layout. Now the important part here is that we were just building this just to see, you know, if it A, worked, which was a big thing. You know, B, what were the performance characteristics of calling a script into the middle of layout for our engine, and a few other things. So I'll just walk over roughly what I did. So basically, for anyone that's seen the Flexbox, you know, code in Blink or whatever, this looks very, very similar to it. You know, have methods like calculate your height, computing flex metrics, resolving flexible lengths, measuring children's height. It's basically the Flexbox algorithm in JavaScript. So what I did is effectively create a callback into this JavaScript context called doLayout. So this registers on doLayout. The C++ layout code will call into this basically with a node wrapper. This node wrapper is effectively a layout object at the moment. It just, you know, wraps a strict subset of the APIs that layout object actually has. It gives you access to things like, you know, it's, you know, direct children, for example, but doesn't go anywhere further down. Is that one? Ah, yeah. Cool. But hey, no change. You can query your children's min and max content contributions and things like that. So I went ahead, I wrote, you know, the Flexbox algorithm in JavaScript. For every single custom laid out element on the page, it spins up a separate script execution context. So I don't have to worry about lots of things at the moment. Performance was initially terrible. Like it was, you know, 30 or 40 times slower than native Flexbox. And this Flexbox doesn't even implement all of, you know, the native Flexbox. It only does single lines. It only doesn't really order the children. Doesn't do basically a bunch of things. So it was cheating, and hence the code was a lot shorter. So this is it working. Oh no, promoting what's that's unfortunate. What? There we are. Is that actually gonna maybe on new queue? All right, hang on. Sorry, live demo. All right, honest, this will work. Okay, you can sort of see things jumping around there. So what we've got here is two elements. The top one is a custom laid out Flexbox, and the bottom one is a native laid out Flexbox. They each have 3 children with some flex scroll on there, some flex spaces, different font sizes, things like that. And same thing here, but you'll see that the resolve style is just display block for the first one, even though it's obviously not doing that. So you can see that the children here are stretched the correct amounts. That's 166, 133, and 100 for a 400 pixels wide element. So all of the stretching is working correctly. If I hope this worked last time. If I increase this, yeah, that's broken. Ignore that. But so the main point here is that it works. So everything was working, everything roughly working. That was great, but the performance was terrible. So I started to dig into this. One thing that was quickly apparent is that we really don't have a good way to talk about the style of an element that's sufficient. So at the moment, on the main thread, if you want to know a style of an element, you basically get back a string. So if you want to know the width of something, you get back a string saying 100 pixels or whatever. There's no way to directly rip out, okay, this is the number 100 and its unit is pixels. So we really need a style OM, similar for things on the main thread like transforms, for example, is another good example, where you can have a big long list of transforms applied to your element. And if you want to know what the nth transform is, you have to go, split it by, basically have to go and pass it. There's no easy object model to rip it, play with it. So this is one huge performance problem for the initial prototype. So basically, this is one of the big reasons why we need CSS properties and values. That's going to add in basically this style object model, which allows us to. Well, hey. Oh wow. Okay. Which is going to allow us to do things much more efficiently, be far more expressive about style on this object. So I did that. Things were progressively getting better. Next big performance thing I ran into was marshalling arguments in V8 and jumping, the chattiness between the C++ code and JavaScript code. If I reduced that, basically everything started to get faster. So that's probably, I don't know enough about bindings or V8 internals to even have a rough statement about that, but basically hacking it so that methods would do things like set a constraint and do a layout, increase performance quite a bit. So with this sort of stripped down, highly optimized version of the API, the JavaScript flexbox was about 1.7 to 2 times slower than the native flexbox, which is pretty good without any really fundamental changing of how the V8 bindings work and things like that. So probably pretty pleased with that. We then started to investigate some other things. There was an idea floating around that we might want to use promises to add a layer of parallelism to doing layout. So the idea here is that if you've got, say, n children, you don't really care what order they lay out in. So what you can do is say, lay out all of your children, each of them will return a promise, do promises.all, you wait on all of the promises. The engine underneath can go and lay them out, on different processes, different threads, whatever. It can return to you and just say, hey, all of my children are now laid out. So I quickly prototyped a promise-based version of this API where layout returns an already resolved promise. Using the native V8 promises, it was already about 2 times slower than the native flexbox. That suddenly blew out to 30 times slower than the native flexbox. So that was a little bit awkward. But what was even more interesting is that we just tried putting in Bluebird or RSVP, a native JavaScript promise library, just to emulate the same thing that V8 was doing. And it was only then about 4 times slower. So sort of, these are micro benchmarks, obviously, but sort of indicates that there's sort of some low-hanging fruit in the V8 engine for promises there. I think there was one more thing I was going to talk about. Escaped my mind. Oh well. So yeah, that's demo. Yeah, I can talk about that. Thank you, Aitan. So this is currently running in one script execution context per layout instance. There's one great thing that this allows you to do is that if you've got, say, 10 different custom layouts on the page, it allows you to basically run them on completely separate threads and really not have to worry about them mangling and changing state behind each other. The issue with this though is memory. So if you need to load up, say, the same large, this isn't that large, but say the same large JavaScript library in every single context is suddenly blowing up memory. You've got multiple V8 contexts all over the place. It starts to get a little bit nasty very quickly. The other thing that I observed with this approach is when I nested the flexbox, the custom layout flexboxes, performance, instead of going from 2 times, started to go out to 5 or 6 times. I think this is just purely because of code locality. Instead of just hitting the same JavaScript over and over again, it had to jump around quite a lot. So there's a little bit of a trade-off there as well. So current thinking is that we probably want to go for a single script execution context to run all of this in, and then potentially allow for parallelism on, say, subtrees later. But there's lots of lively debate about that internally and with other browser vendors as well. So I think that's all I had to say. Are there any questions for either myself or Shane?
Don't forget, if you want to ask questions, to use the mics so that they're captured on the...
Rob, I amazed you with my very polished demo, which totally works and isn't smoke and mirrors. It's not smoke and mirrors, it's working.
So I recently saw that Flipboard released a new version of their web app where they, for performance reasons, I think, instead of using all of the normal rendering, they implemented all of their own on top of Canvas and built their own virtual DOM and all that kind of stuff. Mm-hmm. Will this help them kind of achieve performance by only having the custom kind of rendering and custom layout for what they need to do so they can bypass some of the slower things, or is this inherently going to be more slow and not work for someone like them?
I think it should help them. Really, we expect all of the Houdini specs a lot of them to be used by framework authors, like say a version of React or something like that. I'd have to dig into why they did all that stuff that they did, but the whole reason that I'm doing this project is because I think I came from being a web developer angry that I couldn't muck with the internals of the rendering engines and it just wasn't performant. To do things like custom layout, to do efficient paint effects as well. So it should help them. I don't know if we'll, yeah.
I read the same write-up, and I can tell you one thing that they mentioned was doing animation effects that were triggered by animations that were triggered by scrolling events were horribly slow for them. So I can.
One of the Houdini specs, the asynchronous style specification or compositor worker should definitely help with that very much. Yep.
Tim.
I just wanted to make Mike run across the room. Have you looked at how much this is Chrome's particular architecture that's making your JavaScript slower versus how this might happen in Mozilla or something like that?
Yeah.
You can take that one.
Yeah, so the promises using just a library JS version of promises versus the native V8 promises indicate that there's most likely some low-hanging fruit there. I really don't know enough about V8 bindings and all of that stuff. If there's optimizations that we can do to make entry and exits more quicker, I really haven't spoken to the V8 team much about this yet.
We do know that those are expensive.
Yeah.
It's just whether it's easy to fix them.
Yeah. But basically, like, our implementation details of how quickly we can jump in and out of V8 shouldn't affect how we write the specs. It should be it should be, you should write specs in a reasonably efficient way, but it shouldn't say, oh no, V8 can't do this, therefore we shouldn't do promises or whatever. Cool. All right. Well, if you've got any ideas, thoughts, questions afterwards, feel free to chase down Shane and I with pickaxes or something like that.
Or without pickaxes, that's good too.
Sure.
Yeah.
I was just thinking of Minecraft pickaxe. I don't know. Thanks for your attention. Mike, over to you.